Hello. The lesson for today is piecewise defined functions. In this lesson, we'll study individual functions that are defined differently depending on the value of the independent variable. For instance, perhaps the function f follows our rule that squares x if x is less than or equal to 3, but f follows a rule that negates x if x is greater than 3. We would write, now you notice we have some new notation for this situation. We have a left side of what appears to be like a curly bracket. This is what separates the rules. So what's happening is f of x is equal to x squared if x is less than or equal to 3. F of x is equal to negative x, or the opposite of x, if x is greater than 3. That's what was the description, the line above the rule. Now suppose we want to evaluate this function, f of negative 2. Which rule do we follow? We follow the first rule because negative 2 is less than or equal to 3. So we have negative 2 squared, which is 4. F of 0. Again, which rule do you follow? You follow the first rule because 0 is less than or equal to 3. 0 squared is 0. F of 3. Which rule do we follow? Well, it's the first rule again because notice the first rule is x is less than or equal to 3. So x being equal to 3, we still are using the first rule. 3 squared is 9. Now, if I want to evaluate f of 4, we're on the second rule because 4 is greater than 3. So we're going to have the opposite of 4, which is negative 4. When evaluating a piecewise defined function, you first consider which rule is to be used before performing any operations. Let's do some more examples. Let's say we want to sketch the graph of this piecewise defined function. Notice that the different pieces, they are linear. We're familiar with both of those graphs. They are lines, of course. We're going to use the first rule if x is strictly less than 2. We're going to use the second rule if x is greater than or equal to 2. What you want to do in this situation, most likely, is graph both of these lines separately, and then we'll put them together in the next step. Y equals x plus 1 is given by this graph, and y equals 2 minus x is given by the second graph. Now we're going to put them together at x equals 2. Now you realize there's going to be a jump, and y can only be one thing at a time. So which rule is going to have the closed circle is the one with the or equal to. So what's going to happen is at x equals 2, there's going to be an open circle at 3. So notice that our graph actually has a jump. Again, if x is less than 2, we follow the first rule. If x is greater than or equal to 2, we follow the second rule. Now in the future, we're going to be doing a few other problems that are similar. Let's look at what I would have planned for the next class or two. We could try to sketch this piecewise defined function. See, one half is going to be a parabola and the other is going to be a line. You should realize that we're not limited to 2 pieces. We could have 3 pieces. So again, we have 2 different lines, the first and third rule, and the middle one, perhaps you recognize that as being a semicircle. I would also like to point out the possibility of a real world problem, and this will be the last problem that we will look at today. Many southwestern states have a limited water supply, and some state governments try to control consumption by manipulating the cost of water usage. Suppose for the first 5,000 gallons a household uses per month, the charge is 5 cents per gallon. Once 5,000 gallons is used, the charge doubles to 10 cents per gallon. Suppose the cost to a household during a hot summer month was $1,150. Determine the number of gallons of water used that month.